Okay, in this video, I'm gonna do problem 16.7 from your book. So this problem, we have a mechanism, like, hold on, turn my document camera. All right, so this is the problem trying to do. This problem says we have this brake system, and we have actuating force acting at the end. And then when you apply force to that, then through this linkage, you will have force acting applied on the shoe. It will press the shoes on that disc and to, generate the brake power. Braking torque. So the problem statement says that for this mechanism, um, assuming that coefficient of friction is 0.3 and the face width of the shoes are 2, find the maximum actuating force that will result in, knowing that the maximum pressure that the shoe can tolerate is 150 psi. So the limit for the pressure on the shoe is 150 psi. Knowing that, find maximum actuating force that can lead to this maximum pressure. And when that happens, what would be the braking torque? So in other words, knowing the limit, material limit on the shoe, we want to see how much total braking, maximum braking torque I'm going to get out of this system. All right. So this is what we are trying to do. All right. This problem, as you see, this is not a drum or internal shoe. It's actually system like this. So you have external shoe acting on your disc. All right. All right. It's like a cylinder. We have this brake applied to it. So what is important here? First, a problem like this, we have to figure out what type of brake you have. So now we have this external brake, and the dimensions, look at the dimensions. C is the distance from your hinge to where the force is applied, your actuating force. And this distance is measured based on the direction of your force. So if you have the direction of the force, you should have a line parallel to your force, and then that distance will be your, your C. That is actually your torque arm, your moment arm for force F, right? Taking your moment about this. Okay, and other thing and then A is the distance from the center to the hinge. I'm trying to review what we had. So, and theta 1 is the angle. We measure the angle theta from the hinge. So connect the hinge to the center. We define x coordinate like that, x-axis. Theta is measured based on the angle from x. Theta 1 is the angle at which the shoe starts. It doesn't, if you remember, I said that if you put the shoe starting from here, it's not useful, productive, because there will be zero pressure here. So it's better to have it starting from angle like theta 1, and then starts at theta 1, ends at theta 2. Measured both from x-axis. All right, so be careful about that. And as I said, A is the distance between your hinge and the center. And the rotation, okay, the radius of this disc is R. So this geometry, we should have all the geometrical properties. And next thing I need to figure out, and which is very critical, important, is you have to see if the system is self-energizing or is not self-energizing to find your, your forces. All right. So So 1612, 1611 was for non-self-energizing system, non-self-locking system, external one. And 1613-14 was for self-locking one. And in this, we had this equation relating your moment of the friction force and normal force to your actuator. And same thing here for self-energizing one. And MF and MN integrate, like the moment of friction force and normal force. This equation is the same for both of it. So we need to figure out, theta 1, theta 2, A, and other variables to find my MF and MN, and then find your actuating force. So a strategy for this problem will be this. We need to figure out at what brake, what shoe we are going to have maximum pressure, and that maximum pressure is given to me. B is given to me, R is given to me, F is given to me. Maximum pressure happens at angle 90, so theta is 90. R, I have. A, I can find it. Theta 1, theta 2, I can, looking at the geometry of the problem, I can find them. And you put them here, you will have your MF, you will have your MN also similarly calculated. And then we come here, based on, we will look at the larger, the brake shoe that has self-locking, because pressure on that one is going to be larger. So I have an MN and MF for it, and I have C, so we can find actuating force that's going to result on that pressure. So once I have that, then I can move to the other shoe, which is not self-locking, and then find pressure in that one. We don't know how much pressure is on that one, so we can go here and then now find our pressure. For non-self-energizing ones, we don't know how much maximum pressure is going to be on that one, all right? Because it's going to be smaller than what maximum that problem statement gave us, all right? So first thing first, let's see if we can figure out which one of these is going to be self-energizing. And which one of them actually is going to have larger pressure. So I have a ground everything here. So, and okay, so we have this linkage here, right, and 5-inch distance here, the length. Right. So we have this arm length 6, this is 4, and we have the shoe here and the shoe here. So third thing we know, why we use this arm. This arm actually is gonna give us mechanical advantage to boost our force. Because of the lever difference, you see that if your force is F here, on the other side is gonna be 4F. So I have free body diagram of that L bracket, this L bracket here, right? That L bracket, look at this side. This side, this arm is 2 force members, so I'm gonna have force like acting in horizontal axis. So if you take, let me rewrite that. So I'm gonna need this. I don't want to redraw that figure again because it's gonna be time consuming. So I'm gonna do that piece. All right. So let's look at that L-shaped bracket. That member is a 2 force member, right? So the force is gonna be, if this force is this direction, and this is like a hinge, this force should oppose that. Right? So this should make it counterclockwise. This is making clockwise, counterclockwise. So if this force is F, and this arm was 16, this one is 4, right? So this force must be 4 times of my actuating force. So let me call it actuating force. And then if you write equations of equilibrium for x, summation of force in x and y direction, this one is going to be F actuating, and then this one is going to be 4 times of F actuating. So to have equilibrium, you have these. All right, so this actuating 4 times of it is going to go directly on this one, on this side, on this shoe. And if you look at the other one, the other shoe, now let me bring it here, this figure. So I have the left shoe, 4 times of actuating force is going to go on the left shoe. And on the other side, we saw those two forces, action, reaction. Those two forces are going to change their direction and it's going to be acting on the end of the other shoe. So this is going to be F, this is going to be 4F, and this force, which is my total actuating force, will be vector summation of these two guys, right? So this will be radical 4, 4 squared 16, 1 squared 1, so we'll have the radical 17 of actuating force. So the total actuating force that will be acting on the right side will be radical 17 F actuating force. All right? So this is almost 4 times of F, right? So looking at these two systems, these two guys, let me zoom out. Which one is going to be, self-energizing? Maybe let's look at this one. If you look at this one, the friction is this direction. Friction moment is actually, I'm rotating, my disk is rotating clockwise. So the friction moment is going to actually, for this one, is going to try to separate this shoe from the surface of the disk. And on this one is opposite. The friction actually is going to help to press it. So it's obvious the left one is going to be my self-locking one. And how much is going to be my pressure there? The Powell statement says that we don't want to have our maximum pressure exceeding 150. So pressure at that maximum point is going to be 150. And at what angle is going to happen? At angle of 90, this will happen, where your shoe starts, right? So 90 degrees from here, I'm going to have that getting maximum. All right, so I figured that the left one is self-energizing, so the pressure on that one is going to be 150. So now I can move on and find my, I'm sorry, 90 degree will happen from the hinge. So 90 degree from the hinge, you are going to have maximum pressure, okay? So if you have the brake shoes started from the hinge, then it will be from the brake. But 90 degree from the hinge, you're going to have your pressure maximum from the hinge, right? So, okay. So I know that PA is going to be 150 there. So I need to find now MF and MN, right? Yeah, I showed you the strategy. I'm going to need MF and MN. For self-energizing one, I know what his maximum PA is. So knowing these, we can find F actuating, limiting force for actuator, okay? So we find that, and then we move on to the one which is not self-locking and find pressure for that one, all right? So let's write our equation. This is important. uh, to figure out our variables right. So let me rewrite this MF here and see what we have and what we need to find. Okay, so MF is FPA BR divided by sine of theta A, theta 1 to theta 2, and then sine of theta R minus A cosine of theta d theta. All right, so look at here, see what I have. We are looking at, by the way, for the left one, right? Self-energizing. So I have F given to me was 0.3, problem statement gives it to me. Pressure, I know it's going to be 150 for that. B is given to me is 2 inches. R is given to me is 10 inches. I know that that's going to happen at angle of 90, the max, so this one is going to be 1. All right, so R again, I have it here is 10. A, I need to figure out, and theta 1 and theta 2, I need to figure out too. So let's see how much theta 1 and theta b are going to be. So we have to look at this figure. Theta 1, as I said, is the, okay, when we define our coordinate, let me draw that left shoe again. Something like this, right? And it's like this. All right, the shoe starts here and goes up. All right, so I have the center. Probably I went too much, but okay, let's say. Okay, the Paula statement says that the angle, if they have vertical line, this angle is, oh, I'm sorry, it says that this angle between the vertical line and where the shoe starts, the problem statement says that this is 20 degrees. So let's look at it here, maybe it's clear. You see here, from vertical line to where the shoe starts is 20. Let me zoom it. See, from the vertical line to where the shoe starts. But theta 1 is measured from the hinge to where the shoe starts. So I need to find theta 1, right? So if that angle is 20, this total is 20, I need to find this angle, and then once I have it, then I can subtract it from 20 to find my theta 1, which is this, right? This is theta 1, and theta 2 is the angle again measured from the hinge to that last point. So this is theta 2. All right. So this total is 20. This angle, how much is going to be? The problem statement says that this distance, this one, this distance is 12. And it says this distance from the vertical line to the hinge is 3. So 3 inches here, and this one in this right triangle is 12. So we can go arc tangent of 3 divided by 12 and then find this angle. Right? Once I have that angle, I can find my theta 1 by subtracting that angle from 20. So let's see how much that angle is going to be. Let me use my phone as calculator. All right. See what I have. Okay. So 3 divided by 12. Arc tangent of 3 divided by 12. This is giving me this in radian, but let me change it. How can I change this? Radian to, oh, okay, grad and degree is 14. Okay, you guys see that? It's hard to see. Okay, let me. All right, so hold on a second. I'm getting message that my voice is so low, so let's see what I can do. Hello? Yeah, I don't know what is wrong with my microphone. Microphone adjustment. Microphone setup. All right. This is a problem I always have with the microphone with the Pnato. I don't know why it's I always have it too low. Okay. So I will try to speak louder. All right. So you guys are not able to see my screen of my calculator, but the angle is like 14. So I found 14. This angle is 14. This is 14. So theta 1 is going to be 6 degrees. And then theta 2 is going to be 6 plus 130, right? 136. When you're taking integral, you have to be careful to put your angles in radian. And then if you did that, you put this here, I can find my MF. MF, okay. So we need to take integral. So let me change my angle to radian, and then I'll put all those numbers. 0.3 times 150 times 2 times 10 times then integral. Integration of my function, sine of theta or sine of x. Okay, sine of x, what is x? Alpha x. Alpha, okay, I need to hold this. Alpha x times my r, which is 10, minus, oh, a. I need to find a. Okay, so let me tell you how we can find a. Okay, so okay, a. If you hold on a second, I am putting this formula into a calculator, and then I explain a to you guys. Okay, so let's look at a. I told you guys that a was the distance between your hinge and the center. So let's look at my figure, see what is that distance. Looking at here, this is what I'm looking for, the distance between the center and your hinge. So what is that distance? It's kind of is obvious what that is. This is 12, this is 3. On this right triangle, A is gonna be 12 squared plus 3 squared. So you will have it like 12 point, I think 3. 12.3. Let me calculate that. 12.4, I think. So 12 squared plus 3 squared. And then answer 12.36. So 12.4. Okay, let's say 12.4. All right. So this goes here, 12.4. So I need to take this integral and find the number, okay? So now let me look at my calculator. 0.3, okay, 150. Okay, 1 times 150. I don't think you guys can see this. And so 150 times 2 times r, which is 10, and the integration from 6 degrees to 136, sine of theta, and then times 10 minus 12.4 cosine of theta. So if you did that, you're going to get 12,799.5. Okay. You can maybe round it to 12,800. The unit is going to be pound inch because I had the pressure in psi, everything else was in inches, so we have pound inch. Next, I need to find mn. Let's write that formula also here. Let me bring it over again. I'm talking about this formula. All right. So mn is gonna be, okay, I'm gonna plug numbers here. PA is 150, BA is 2, right? And R is 10. What is, okay, I have A also there in that formula. You see A is 12.4, sine of 90, which is 1, and then angles again from 6 degrees to 136. Again, remember to convert it to radian. And this is my mn. So let's see. Okay. I have to modify what I have here. 150 times 2 times 10 times 12.4 times my integral. And my integral, it changes now, is going to be sine of x squared. Oh, okay. Sine of x squared. Squared. All right, so I'm getting 53,000. Okay, I want to add additional parentheses here to make sure that, okay. Yes. So what I'm getting is this, 53,429.9, so let's call it 30. 53,430, again, pound inch. 53,430 pound inch. All right, we are there. So we know that left one is self-energizing, so the force, okay, mn was 53,430 minus mf was 12,800 divided by, what is my c? C is the distance between my force and my hinge, all right, and measured based on the direction of my force. So this force is, if this is my actuating force, the good thing is it's parallel to horizontal axis. So the distance c for this one is going to be actually this distance, right? This is my c. Formula statement, let's look at, see what that distance is. If you look at here, I have 12, 12, and 4. You have to add all of them. That makes my c for the left side. So 12 and 12, 24, with 4 will be 28. So my force, my limiting force, is going to be this. All right. It's going to be 53,430 minus 12,800 divided by 28. Okay, so I found my force, 1451 pound. All right. But going back to the problem. You remember this that force that we found is the limiting force that we get here. But if you want to find your unknown force in terms of the actuating force here, that actuating force is going to be 1/4 of this. So maximum actuating force is going to be 1451 divided by 4. Divided by 4. So I'm getting 363 pounds of force, actuating force. All right, so we found it. Now problem statement says, what else it says? It says that, okay, we found this limiting force. Find the limiting force and then torque capacity. All right, so now we have to do torque capacity. Find the torque capacity for, if you remember, in class, we found the relationship for, hold on a second, I'm going to show you. Okay. All right, for actuating for the torque, see if I can find the equation here. Now let's first find the pressure on the right side, on the right shoe, this shoe, and then I will find the actuating force. So the right shoe is not self-locking, but now I know that the limit on the on the force actuating force. So I'm going to put that force on that one and see how much pressure I'm going to get on that one. So let's look at that. The right shoe, I have my hinge here. Again, because of similar, we have similar geometry. So if I connect my center to that, my center is going to be what? I'm sorry, my angle, theta 1, is going to be again 6 degrees. And then you go up, theta 2. So theta 1 will be 6. Theta 2 will be 136. And what else? MF and MN, the equation we had, is going to be the same for this one. So, but, I'm sorry, I don't know this time the pressure on that one. So we have to find the pressure is unknown this time, right? But, okay, so what I know is that for that one, the right side is not self-energizing, so I have this equation, right? So I know my actuating force, that times C should give me Mn plus Mf. Mn and Mf, the only thing I don't have for the right side is the pressure, maximum pressure. So that comes to this equation, and I can find PA, maximum pressure, from this equation, right? Because I have the force. For the left side, we knew the pressure and we found the actuating force based on that, but this one is opposite. All right, so you have to do same thing here. And Mn and Mf, I found for the other one to be these two numbers, right? So let's see how much A is going to be for that one. A was the distance from the center to the hinge, right? So for this one, it's going to be the same. A is the same, R is the same. If you look at the equation for MF and MN. So for those two shoes, thetas are the same. R is the same, A is the same, F is the same, B is the same, everything is the same other than the pressure. I don't know what the pressure is, right? So it's unknown. I already calculated these two guys. So what I'm going to do, I know that MF is going to be the same. It's going to be the same. The only thing, if I divide this by 150, then MF for the right side is going to be this divided by 150 times PA for the right side. And I don't know what pressure we have, right? So 12,800, it's like a shortcut. 12,800 divided by 150, I get 85.3 times PA, right? And MN is going to be 53, 430 divided by 150. So I get for that one 356 times PA. All right. So I have these two, and I know that for the right side, MF plus MN, because it's not self-energizing, they're going to be added to each other, divided by C, should equal my actuating force F. So we have to find, I have these two guys in terms of PA. So this one is 85.3 PA. This one is 356 PA. I need to find C and F for the right side. Let's look at this. All right. And okay, so what is my total force? When I say force, I mean total actuating force. It's not the parallel one, it's not this one, it's the total one. The total force for the right one, if you remember, I said it's going to be radical 17 of actuating force, F, right? So I have here radical 17 times F actuating force, which I have. What was it? I have it here, 363. All right, and then on here, I have these two added. Let's add them together. So I'm going to have, this is almost 80, okay, 85. So 85 with this, I'm going to get 1, get 6, 4, and 4, right? 4, 4, 1. PA divided by C. Let's figure out the C. So what is C? C is the distance. If you remember, I said that you have to draw a line parallel to your actual, your total force, and then this will be your distance, right? You see. So we have to figure that force, that thing. All right, for that, I'm going to need probably like a cleaner picture. All right, so let's see how we can figure that. Let me see if I have it here. Okay, yeah, let me draw a picture. I thought that I have the picture here so that I save time not drawing again. So let's look at it here. So I'm looking at the right side. So you see that I have this going like this, like that. So, and then like this. My force, I have two components for that. One of them is, okay, it's going down. If it is like F, this one is like 4 times of that, 4F. So this is my resultant force. All right, so the question is, I'm going to need this angle, right? So this angle is going to be actually a small angle because this is F, this is 4F. So this angle is going to be arc tangent of 1 divided by 4. So let me change my unit to degrees. So arc tangent of 1 divided by 4, I get 14. All right, so this is 14 degrees. All right, so what else I have? Okay, I know the distance, looking at here, from here to here is, what is, this is 12 and this is 12. But what I'm interested in is this distance. This distance, right? This one. This is my C. All right. So if you continue this line, if you look at the figure, I have this one 5, but this one is 3. So if I have this one going down, I'm going to have this here equal to 2, right? This will be 2. What is this distance, this total? It's going to be equal to 24, right? So this is, again, this is equal to, I have 12 here, and I have 12 here. So what is going to be my C? Let's see. And this angle is 90. Okay, if this is 14, this one is going to be 76, right? Because this is perpendicular to that. All right. So, all right. If I connect this to here, let's see what I get. Connect this to that. This is 2. This is 24. So this will be, we can find this length. And then in this right triangle, probably we can find my C, right? So that's probably the way to go. All right. Yeah, is it the best way? Okay, let me see. This angle, as I said, is 76. So how much is going to be this angle? Yeah, we can figure out this angle by arctangent of 2 divided by 24. So let me write that angle here. Arctangent of 2 divided by 24. I'm getting 4.8. So 4.8 here. And then this is 76, so minus, oh, I'm sorry. Minus 76. I'm getting 71. Okay, so this angle is 71. All right, so I have that figured. Let's see. This distance is 24. I can find this now, and then after that, I can go this sine of 71 to find C. So this distance is going to be slightly larger than 12. So what is that? It's going to be, I'm sorry, larger than 24. So cosine, okay, that thing, x, if I call it x cosine of 4.8 should be 24. So x will be 24 divided by cosine of 4.8. It's going to be very close to 24. 24 divided by cosine of 4.8. 24.1 inches, basically 24. And then here, if I go that thing, sine of 71, I'm going to find my C, which is 22.7, 22.8. All right, so C is 22.8 for the other one, this one, okay? So let's see where I put my other paper. All right, so go back here. Now C is 22.8. Then actuating force was 363. So I found PA equal to this other side and then divide by 4. All right, so let's see. 22.8 times radical 17. Okay, and then times my 363 total divided by 441. So my pressure turns out to be 77.4 psi, almost half of what I have on the left side. Right? So I found the pressure. So now we are ready to find our torques.